9 plants, and I'm going to name every one of them and tell you exactly what job each one does. Together, they will process the waste in your aquarium, hold your water stable, and run the tank without a filter running on it. I want to be exact about that last part before we go any further, because the claim is conditional rather than universal. This works with heavy planting and light stocking, and you still need gentle water movement at the surface, which an airstone provides for a few dollars. What you do not need is a filter, but the plants are not the interesting part of this video. The interesting part is what is sitting in the plant section of your local fish store right now, because a significant share of what is sold there as aquarium plants cannot live underwater at all. And that single fact has done more damage to more beginners than anything else in this hobby. Here is the sequence that plays out constantly. You decide to plant your tank. You go to the store and buy 6 or 7 of the nicest looking plants in the display, the ones with bright color and interesting leaf shapes, and you plant them carefully. For 3 weeks they look superb. Then one starts yellowing from the base, another goes translucent and begins to fall apart. A third loses its color entirely and turns to mush over about a week, and every piece of that mush is decomposing in your water. Your ammonia ticks up. Your algae takes off because the nutrients from the rotting plants are going straight into the water column. You replace them with more of the same plants because they were the good-looking ones. And it happens again. 6 months later, you decide you have no talent for plants and you buy plastic. And the entire time, the problem was that 3 of the plants you bought were never aquatic in the first place. Put a figure on that year. Those plants run $3 to $8 each, and a stocking of 6 or 7 is $25 to $50. Replace 2 or 3 times, which is $75 to $150. Add the algae treatments bought to fight the bloom the decomposition caused. Add the filter, the media, and the electricity that a properly planted tank would have made unnecessary, which is $60 to $200 up front and a running cost after that. And the plants that actually work in this video cost almost nothing, because most of them grow fast enough that hobbyists give them away by the bag. Search any local fish keeping group and you will find people offering hornwort and water sprite for the price of collecting it, purely because they have run out of places to put it. That last point is the whole commercial explanation, and it is worth being direct about it. Terrestrial plants sold as aquatic ones are profitable precisely because they die. Mondo grass, dracaena, various decorative crotons, and similar houseplants appear in aquarium displays regularly, held underwater in a shop tank where they survive for weeks before declining. And a plant that dies in your tank in 3 months is a plant you buy again. Meanwhile, the genuinely useful species are commercially hopeless. Hornwort doubles in a couple of weeks. Duckweed multiplies until you are throwing it away. Nobody who owns those plants ever buys them a second time, and most of them end up handing bags of it to other hobbyists for free. That is not a scandal, and almost every consumer category on Earth follows the same logic. What matters is that the selection in front of you is filtered by what can be sold repeatedly, rather than by what works. There's a simple test you can apply in the shop, and it costs nothing. Look at the leaf. Genuine submerged aquatic plants have thin, soft, often translucent leaves with no waxy coating, because a plant living underwater has no need to prevent water loss and every reason to maximize contact with the water around it. Terrestrial plants have the opposite construction. Their leaves are thick, stiff, glossy, and waxed, because that waxy cuticle exists to stop the plant drying out in air. If a plant in an aquarium display has firm, shiny leaves that feel substantial between your fingers, and especially if it has stiff, upright, variegated blades, you are almost certainly looking at a houseplant in a fish tank. Ask for the scientific name. If nobody can give you one, put it back. Before I get to the 9, one thing worth saying now. A plant-driven tank is a system where lighting, stocking, and feeding all have to line up, and the plant list on its own will not carry you. I have put the complete version together in one place as a full aquarium playbook, covering how every layer supports the others. The link is in the description and in the top pinned comment, and if the code is on your screen right now, you can scan it and go straight there. Now, here is what is actually happening, and there is one piece of plant biochemistry that explains the entire method. Everybody in this hobby learns that the nitrogen cycle runs ammonia to nitrate, performed by bacteria, and that plants then consume the nitrate at the end. That is true, and it is also the least important half of the story. Aquatic plants take up ammonium directly, and they prefer it. The reason is energetic. To use nitrate, a plant must first convert it back down into ammonium inside its own tissue, using enzymes and expending energy to do so, because ammonium is the form that actually gets built into amino acids. Given both in the water, a plant takes the ammonium first every time, because it is already in the usable form and costs nothing to process. Follow that through and the implication is large. In a densely planted tank, plants are not waiting at the end of the chain for nitrate. They are competing with your nitrifying bacteria at the very start of it, for the ammonia the moment your fish produce it. And plants are extremely good at winning that competition, because a plant with an established root system and a large leaf area is drawing continuously from the entire water column. What that means in practice is that a heavily planted tank frequently does not need a bacterial colony to be safe, because a large share of the ammonia is being intercepted before the bacteria ever reach it. That is why a properly planted tank can be stocked without the 4 to 6 week wait that a filtered tank demands. The plants are not assisting the cycle, they are shortcutting it. There is a second thing happening that nobody credits, which is that your plants are also your filter media. Nitrifying bacteria live on surfaces, and a densely planted tank is almost nothing but surface. Every leaf, every stem, every millimeter of root, and above all a mat of moss, carries biofilm containing the same bacteria that live in your filter box. A well-grown tank presents a colonizable surface area far larger than anything that fits inside a canister, so you are not removing the biological filter when you remove the box. You are distributing it across the entire aquarium, where it sits in the water it is treating, rather than in a sealed container in a cabinet. There is a third contribution that runs alongside both of those, and it is the one that makes the whole arrangement stable rather than merely adequate. Through the photoperiod, your plants are releasing oxygen directly into the water as a byproduct of photosynthesis, and they release it everywhere at once rather than at a single outflow. Nitrifying bacteria are aerobic and their conversion rate depends directly on available oxygen, so a heavily planted tank is feeding its own bacterial population. The oxygen it needs to work, at the same time as it is competing with that population for ammonia. The two processes are not in conflict. They run in parallel, and between them very little ammonia survives long enough to accumulate anywhere, and that is what makes the wrong plants so damaging. A terrestrial plant submerged in your tank does not simply fail to help. It dies slowly over weeks, and the decomposition of that tissue releases ammonia and phosphate directly into your water, which is the precise opposite of what you bought it to do. So the beginner who buys 3 of them has installed 3 small ammonia sources, and then watches their algae explode and their water quality slide, and concludes that live plants make a tank harder to manage. They were not doing anything wrong. They bought plants from the plant section of an aquarium shop. The first is hornwort, scientific name Ceratophyllum demersum, and it is the engine of this entire system. It has no true roots, it simply floats or gets wedged into place, and under decent light it grows faster than anything else on this list, adding several inches a week. Growth rate is uptake rate, so nothing strips nitrogen out of your water faster. It is also the plant to use during the first weeks, when the tank has no established anything and needs a large sink for ammonia immediately. 2 practical notes. It drops needles when it is first introduced, or when conditions shift, which alarms people and is normal. And it is genuinely tolerant of cold, which makes it the one plant here that works in an unheated tank. The second is Amazon frogbit, scientific name Limnobium laevigatum, and it covers the surface layer with an advantage no submerged plant has. Its leaves sit on top of the water and take carbon dioxide from the air, where it is available at over 400 parts per million, rather than the few parts per million dissolved in your tank. That is an enormous head start, and it is why floating plants outgrow submerged ones so consistently. Underneath, it trails long fine roots into the water column that both absorb nutrients and provide shelter for fry and shrimp. It also shades the tank, which suppresses algae on the glass and substrate below. Keep it off the surface directly above any airstone, because constant splashing on the leaves causes them to rot. The third is duckweed, scientific name Lemna minor, and I am including it deliberately, even though most of the hobby treats it as a curse. Duckweed is the fastest nutrient exporter available to you, doubling in as little as 2 days under good conditions. The reason it is hated is that you cannot get rid of it once it is in, and that is a genuine warning. But look at what that complaint actually describes. It describes a plant so productive that it removes nutrients faster than you can supply them. You net a cupful out every week, throw it away, and every scrap you remove is nitrogen and phosphorus physically leaving the aquarium. If you want a controllable version, use frogbit alone. If you want maximum export and do not mind the appearance, this is the most efficient thing you can put in a tank. That is 3 of the 9, and this is the point where how you combine them matters more than the individual species. A filterless tank needs the fast growers and the slow structural plants in the right proportion, established in the right order. The full playbook covers the planting plan, the stocking sequence, and the lighting that makes it hold together. The link is in the description and the top pinned comment, or scan the code on your screen, and it will take you there directly. The 4th is water sprite, scientific name Ceratopterus thalictroides, and it is the flexible one. It will float on the surface or root in the substrate, and it grows quickly in either position, which makes it the plant you use to fill space fast, while the slower species establish. Floated, it produces a dense tangle that fry survive in. Planted, it builds a substantial root system quickly. It is also the plant to reach for if a tank is struggling, because it will grow in almost any conditions and it responds fast, so it buys you time while you correct whatever is actually wrong. The 5th is Vallisneria, scientific name Vallisneria spiralis, and it works the substrate. It sends long roots deep into the bed and spreads by runners, and that root network does something no water column plant can, which is release small amounts of oxygen into the substrate around it. That keeps the bed from going anaerobic in the lower layers, which matters enormously in a tank with no filter driving circulation. One warning worth knowing, because it catches everybody out. Vallisneria reacts badly to liquid carbon products and will frequently melt entirely when exposed to them. It also wants some hardness in the water, so it performs poorly in very soft supplies and thrives in most ordinary tap water. The 6th is Cryptocorin wentii, and it is the low-light root feeder that does the quiet work. It is a heavy substrate feeder. It tolerates genuinely dim conditions, and once it settles, it lives for years without attention. It is famous for melting after being moved, dropping all its leaves within days, and almost everybody assumes it has died and throws it out. It has not died. The roots are alive and it regrows from them within a few weeks, usually with leaves better adapted to the conditions than the ones it lost. So leave it alone and let it do it. The 7th is Java moss, scientific name Taxiphyllum barbieri, and in a filterless tank, this is your biological filter media. A mat of moss presents a colonizable surface area out of all proportion to its size, folded into a dense, 3-dimensional structure, and that surface carries the nitrifying biofilm your filter box would otherwise hold. It also traps fine detritus in its structure and hosts the microorganisms that fry and shrimp feed on. Tie it to wood or rock and leave it. If you take one plant from this entire list into a tank running without a filter, take this one, because it is the closest thing to a drop-in replacement for the media inside the box you are removing. A handful tied across a piece of driftwood will spread into a mat over a few months and will keep spreading for as long as you let it. The 8th is Java fern, scientific name Microsorum terrapus, and it feeds from the water column while attached to hardscape, so it needs no substrate at all. Its broad leaves and thick creeping rhizome carry substantial biofilm, and it is close to indestructible in low light. The one rule is that the rhizome, which is the horizontal green stem the roots and leaves grow from, must never be buried. Bury it, and the plant rots from the middle outward. Tie it or wedge it against wood or stone, and it will attach itself over a few months with its own roots, at which point it is effectively permanent. It also propagates on its own, growing small plantlets directly on the older leaves that can be detached and placed elsewhere once they have a few roots of their own. The 9th is Anubias barteri, and it is the permanent structural element. It grows slowly, which sounds like the opposite of what this system needs, and that is exactly why it belongs here. Everything else on this list is being harvested and thinned constantly. Anubias sits on your hardscape unchanged for years, carrying biofilm on tough, leathery leaves that nothing eats and nothing damages, like Java fern. The rhizome stays above the substrate. Between the two of them, you have a permanent structural layer that survives every disturbance the rest of the tank goes through, which matters more than it sounds, because a system built entirely from fast growers is a system with nothing holding steady while you harvest it. I want to be straightforward about the limitations, because accurate information is worth more than a clean sales pitch. The first is the condition attached to the title, and I want to state it plainly. Running without a filter requires heavy planting and genuinely light stocking, and it requires surface movement, because plants consume oxygen at night rather than producing it, and a still surface in a warm tank overnight is where filterless setups fail. An air stone costs a few dollars and solves it. The second is that this system has no reserve. A filtered tank carries a bacterial colony that keeps working if your plants struggle, and a plant-driven tank has no such buffer, so a light failure, a bad melt, or an impulse purchase of 6 more fish hits the water immediately. The third is that it suits particular fish. Small, low-waste community species work beautifully. Goldfish, cichlids, large plecos, and anything that digs or eats plants will dismantle it, and you get no mechanical polishing at all. So expect water that is healthy rather than showroom clear. Now, here's the mistake that collapses this entire system, and it is the same mistake every time. Adding fish too early. In a filter tank, you cycle the filter and wait for a bacterial colony. In a plant-driven tank, the plants are the filter, and an aquarium full of plants that were put in last Tuesday has almost no processing capacity because uptake is proportional to living plant mass, and there is barely any yet. So the correct sequence is plants first, alone, for 4 to 6 weeks, until you can see obvious new growth, and only then fish, a few at a time with several weeks between additions. Every instinct will tell you the tank looks empty and ready. It is not empty, it is growing, and the growing is the cycling. None of this is a modern experiment. The aquarium was invented as a filterless system, and it worked. In 1850, a British chemist named Robert Warrington set up a glass tank containing goldfish, aquatic plants, and snails, and demonstrated that the three could sustain one another indefinitely, with plants consuming the waste of the animals and returning oxygen to them. He called it the balanced aquarium, and that principle is what launched the entire hobby through the 1850s. There was no filter because filters did not exist and were not needed. Mechanical filtration arrived roughly a century later, and by then almost everybody had forgotten that the original design ran on plants. If you want the complete system rather than just the plant list, the full aquarium playbook covers the planting plan by tank size, the stocking sequence and timings, the lighting schedule that keeps plants ahead of algae, and how to identify the non-aquatic plants on site before you pay for them. It is all in one place, in the order you actually need it. The link is in the description and in the top pinned comment, and you can scan the code on your screen to go straight to it. And if this changed how you think about what a filter is actually for, give it a like and subscribe because there is a great deal more where this came from.